Good morning, everyone. Or should I say fancy meat computers? Glad to see everybody's having a good time. So, where were we? We did that. 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 This is where we are. Okay. Nah, life is good as long as you don't think about 2EO4. Yes! Oh, I just like jokes, you know? Here's a joke for you. What do you do with a dead chemist? You bury him. Ha! Da-da-da-da-da-da. So, let me see if we have any announcements. Who knows? Who knows if we have any announcements? I certainly can't keep track. That's why I write them down. Ah! Assignment 1 is dropped. That's about the length of it. That's about the length and the width of it. Yeah, so if you actually have taken a look at assignment 1, you shouldn't find it to be too difficult. It's very, very, very easy. Should be easy marks. What do you call an escaped psychic dwarf content? This, escaped psychic dwarf convict. This had better be safe, or I'm not saying the punchline. This better be safe for work. A small medium at large. Ha! Now that I think about it, I think I've heard that one before. There are 10 types of programmers, those who understand binary and those who don't. Yes. So. Right. So, let's keep going then, because we've got a fair amount of time to... we have a lot to cover and not a lot of time to cover it in, as is usually the case. So... main. Some of you guys were asking about the main function last time, so we're going to. I have a slide on it. So, in Python, execution begins at the first line of a script and terminates on the last line. In C, execution begins on the first line of the main function and terminates either when execution reaches a return statement inside of main, or when the program reaches the last line of main. If it does reach the last line of main without an explicit return statement, that's an implicit return 0. A main function is required for compilation. If you have multiple C files that you've hooked together with include statements, a main function should only be in the top level file. Trying to put regular statements into the global namespace will result in syntax errors aplenty. We'll talk about functions in C in excruciating depth in the next few weeks. So, let me just pull up an example. This'll do. That's terrible. Can't read that. Try get it. Get it is much more readable. So. Yeah. So, we start here, we end there. Very good. If you try to put, like, int x is equal to 5, just out here in the middle of global namespace, save that up. You will cause problems. And I won't be there to bail you out. GCC. Hello.c. Oh, it actually worked. Well, there you go. How about warnings? I should at least get some warnings. Yeah. Suggest parentheses. Well, I guess that's setting it as a constant then. That'll set it as a global constant, but if you tried to do an if statement, if x is equal to 5, then, you know, y is equal to 7, something like that. Then you would definitely have, yes, an error. Expected identifier before this. So there you go. So you can set global variables by putting variables into the global namespace. That's why they're called global variables. But, you know, if you try to do anything fancy out here that's not inside of a function, you'll be wrapped on the knuckle pretty hard. I have references to other functions in main. Okay, so all of my code should just be inside the main function. Well, except if you're doing an assignment, in which case all of your code should be inside of a function, and that function should be called in main. So the way that the autograder works, and this is important, so please listen. The way that the autograder works is that it deletes the main function and replaces it with one that's secret that tries out the function that you've written. So if you write the program you're intending to write inside of main instead of inside of the function that we told you to write it in, then it's, it's going to have problems, and you're going to need manual review, and that's just a pain in the arse for everyone. So please just put the code where it's supposed to be. You can have references to other functions in main. Yes, for sure. For our assignments, are we putting anything in main, like calling our functions with some dummy test variables? Yeah, you should do that. You should use main to test the function that you're writing. Yes. For the MT2MP3 repository, should you click Run CI/CD pipelines for external repository to create it? I don't think you need that option, no. Do you do squiggly brackets take the place of colons in Python for C? First of all, they're called curly braces, not squiggly brackets, you heathen. But, yes. Yes, they do. They replace the indentation as well. They replace indentation and the colon. What does the main function actually do? Does it just execute any code that's within it? So the main function specifies the entry point into the program, right? If you were to rename the main function to make it not the main function anymore, like call it Christmas, then if you tried to compile this, you would get in function start undefined reference to main. So unless main is in there, you cannot compile your code, right? So it needs main in there. It's the entry point into the program. And everything is either in main or is has been called by main. So yeah. So there should only be references to functions inside of the main function. Well, I mean, a function can call a different function, right? Like, functions can call functions that can call functions. But, yeah, if you want something to actually run, it has to be inside of main. It's like, in Python, you can define a function, but unless you actually call it from, the 0 tab level, then it's not actually going to run. That's how it works. For the assignment, is it alright if you ask for scanf in main? If you want to, sure. You could, my tendency would be to just hard code the values that you want rather than go to the trouble of setting up scanf, but, keep in mind, anything that's inside of main is going to be deleted. So you can put anything you want in there, and it's not going to have any effect on the grade. But the flip side of that is that you can put anything you want in there, and it's not going to have any effect on your grade. So, do you need to write separate main statements? Nope, if you have more than one main, that's also an error. So, there should be one main function. That is the entry point and the exit point to your program. Yeah. So, the main event. So, the int keyword indicates that the main function returns an integer value. A return value of 0 indicates the program exited normally, i.e. without any runtime errors. Any other return value typically indicates the program exited abnormally, or that errors occurred. So, if you have the freedom in C to determine what the exit code of your program is. Exit codes are very important once you get into, the environment that C programs run in. You can use the exit code of a program to determine whether or not it executed correctly or finished what it was supposed to do. Giving void as an argument indicates that this program is ignoring any past arguments. The void keyword may be omitted. So you can, if you want, just do it like that. That's still valid and legal syntax. So you write your functions for each question outside of the main, and then call all of those functions in the main. Yes. Yes, yes, yes. We provided code templates, so hopefully everything works. Printing strings should be nothing new, but let's go over it anyways. Printf is equivalent to Python's print function. The biggest difference is that printf does not automatically append new line characters to the end of a string. So, for example, if we printf'd from one string to the next, everyone loves Lisp, that gets printed as the following. The only place that it gets split among lines is where you have an explicit new line character that has been added. So that's just something you gotta remember. There we go. String formatting. So, string formatting should also be nothing new, but here are some important differences. In Python, strings are delimited by either double or single quotes. So, hello world with double quotes and hello world with single quotes, that's exactly the same thing. In C, single and double quotes have very different meanings. In C, double quotes delimit strings, and single quotes delimit individual characters. So that's an important thing. That's an important distinction, and it's one of the ways that Python has been lying to you this whole time. According to Python, there's no such thing as a character. In Python, the way that they choose to deal with characters is to deal with them as singleton strings. However, in any real programming language, characters are their own data type. In C, characters are typically 8 bits. So it's a very small data type, and it only covers ASCII and like extended ASCII, the first 256 characters. But yeah, so a string, we're going to see how this works a little later on, but a string in C is just a character array. So it's syntactic sugar for a character array. It has no special properties. It has no special properties aside from those given to it by the array and character data types. So in Python, you had lists and tuples and strings and sets and dictionaries. In C, you have the array, and that's it. You only have arrays. Delimiters. So delimiters are the things at the end that tell you when it starts and begins. So, yeah. So, yeah. It's just the characters at the end of at the beginning and the end that tells you what a thing is. So, yeah. This is a quick review of some of your common escape sequences. New line and tab new line you should certainly know. Tab you might know. If you actually want to insert a backslash, then it's // and if you want to actually insert a quote, then it's /quote. Yes. Yeah, because, like, all anything is really is a number, right? In computing, everything is numbers. But, like, obviously everything is numbers. But, characters, let me see, am I gonna step on my own slides here? No, okay. So, characters, all that is it's an integer which has been mapped to the character map, right? But yeah. What's so special about characters that they made a special type for them? You should be more asking what's so special about strings that they decided to collect a bunch of characters together to make one. Characters came first. A character is, like, yeah. So, Are you a number? Well, right now you are. As you are, as you are communicating through the chat, you are a sequence of numbers. So yes. So clearly a demo is going to be useful here. So char c is equal to x. Char character array string is equal to hello world. So the thing that's different here, right? In C, I'll shorten this so that it's more useful. In C, this here, that's just syntactic sugar for the following. Right? So if you use double quotes here, right? What you're actually saying is that C is equal to an array containing one element, and that's that there, right? That's if you use double, so double quotes there, right? So if you were to do that, but still give it the regular char data type, then that would be a type error. Because that would make this an array, but this doesn't think it's an array. This the square braces here designate the char as being an array. So here, this works, right? It's char. It's spelt char. It's not car. Car means something else. Yes. So let me run this, and maybe if I try to compile this, maybe this will be a bit more clear. So gcc hello.c expected identifier. I've put this in the wrong place because I'm getting ahead of my slides. String array. There we go. Pardon me. So this isn't going to do anything. But yeah, so this compiles. This is correct. If I were to use double quotes here, I would get an error. Or a warning, at least. Warning. Initialization of char from char star makes integer from pointer without cast. So technically speaking, this still compiles, but what you've done is you've actually created... You're passing a pointer around as opposed to the actual data type. You're not doing what you think you're doing. And in fact, what you're doing is you're only going to take the first 8 bits of whatever pointer this happened to create in memory and assign that to C. So, like, if we were to print C here, print F as an integer just for the hell of it, C. Let's see what we get. 4. Now, here's a question. What happens if we put it to single quotes? We get 120, which is correct. Because if I look up an ASCII table, chart, you'll see that the character lowercase, what character was this again? Lowercase x is right here. There you go. Its decimal value is 120. So there we go. We have the correct value being output. So there you go. It is definitely char and not car, yeah. What if I used single quotes for hello? We'll do that one next. If you add double quotes to a single character, it creates an array of length 2. Right, because it has to also put the null termination in. I feel like they should have been making us do this in 1P. Yeah. Well, you're here now, so... Yeah. So, let's take a look at that. So, let's say we wanted to use... Let's comment this out. What if you used single quotes here? Well, this... I imagine this one will actually be an error that fails out on completely, so we'll see. Yeah, error. Invalid initializer. Warning. Character constant is too long for its own type. Yes. So, you know, it's interesting what is and is not an error. Warning. 2 warnings. Overflow and conversion from int to char changes value this to that. So, basically, the thing that you should be getting from this is that you should pay attention to the warnings that GCC gives you, because they mean lots of things. Yeah, so... The problem with Python programming is that, like, it's possible to know some programming using Python, but not, like, you guys are in a different category, right? Like, civil, what the hell do they need to know this for, you know? They're primarily concerned with buildings not falling down and bridges staying up. You guys need to know the nitty-gritty. Like, what we're trying to do here is we're trying to work you toward, like, we're trying to work you down through the computer system to its very fundamental level, like its most fundamental level, because, like, at the end of this degree, in theory, you should be able to create a computer from scratch, right? You should be able to, in theory, create a computer from metal, right? From metal and silicon. So, you know, that's a pretty grandiose claim, and obviously you'd never have time, but, you know, you should have the theoretical basis to be able to create hardware which implements software, and in order to do that, you have to understand how the software is implemented in hardware. So that's, yeah, so that's why you're learning this kind of stuff. You need to know what's under the hood. Yeah, so, yeah, to be honest with you, the whole single versus double quotes distinction occurs in most programming languages. It's only actually a small handful of them that draw no distinction between the two. So there we go. Let's keep going on the slides. Slide, slide, slide. Slide, slide, slide. Slide, slide, slide. Slide, slide, slide. I gotta get done more than 3 slides today. So, reading. Reading values from standard input. The following program uses the scanf standard library function to read keystrokes from the standard input buffer. So, I'm just copy and pasting this is not going to work because it never does. So, we have int I1. Can I copy and paste it, please? Oh, if I look up the LaTeX source, I'd be able to copy it. Aha, I've got the source. There we go. Copy. There we go. So, so this is how this works, right? We create some variables. The scanf function is given the address of that variable. This is the address of operator. For now, just remember that you have to put an ampersand in front of it when you're doing scanf. %d designates integer conversion. If you use f, it's float. D is integer. C is character, S is string, I believe. So if you enter an integer 6, enter a second integer 8, the sum is 14. I don't know why it returned, that previous example returned 4, to be honest with you. There's a guy who made a Turing machine out of Magic the Gathering cards. Yeah. Why did GCC fail the first time I compiled? Because I hadn't saved the file yet. The file didn't exist in the file system. So this is known as a string formatter. It's necessary. This tells the scanf function what data type we're expecting here. So because it's a D, that means we're expecting an integer, which is that's the data type that we've initialized our variable to, so everything works out. The D tag also works in print statements. This is how it works when you're trying to put data into a print function. If you specify a format tag inside of the string, C says C scans through the string looking for those tags. When it finds one, it picks out the any more arguments you've given to printf, and it plops them in. It performs conversion to a string, and then it plops them in. So what scanf actually does is it waits for input from the user, right? So when I execute the program, enter the first integer. That happens, right? It prints that. It's now on this line, scanf. So I enter my number, 7. 7 has been saved to I. Actually, you know what? Maybe I can do this in Python Tutor. Python Tutor. You guys, have I shown you Python Tutor yet? I can't remember if I've done Python Tutor with you guys in this class yet. But it's got a C tutor, so... Maybe this won't work with scanfs, but... Yeah, there we go. So, print output. So, here we are. We have int and int. Print. Enter your first integer. Scanf. Where's the scanf? How do I enter stuff in here? I don't know. Well, I don't think that scanf works here, so I guess I'll just have to do it regularly. We're going to get to the tags for other types as things progress. So, declaring variables. You may have noticed that the above program uses variables. See, variables in C work the same as in other C-based languages, such as Python. In contrast to Python, however, C variables require explicit type declaration. A variable must be declared with a data type, in this case int, like so. Int xy or float z. Variables may also be declared with an initial value. So if you set them equal to something, that's declaration with initialization. Or instantiation. Initialization and instantiation are pretty much the same thing. I use them interchangeably, even though that's not technically correct. So, identifier naming conventions. Identifiers are legal if they contain only letters, digits, and underscores, and do not start with a digit. So that's the rule for variable names. You can't start them with a digit, but otherwise, any collection of letters, digits, and underscores is good. Identifiers are case sensitive. Here are some good practices for identifiers. Starting identifiers with underscores may cause conflicts with identifiers generated by the compiler or with the standard library. So generally speaking, avoid having an underscore as your first character. You should always use meaningful variable and function names, unlike in the previous slide. By convention, variables and functions begin with a lowercase letter. Multi-word variable names can be either separated by underscores or written in camel case. Scanf and standard input. The standard library function scanf... Oh, that's interesting. I guess I skipped that slide, eh? Skipped those two slides. Can't have. Okay. The standard library function scanf reads characters from the standard input buffer standard input. The first argument is the format control string, which indicates the data type that should be input by the user. This D means int, F means float, S means string. The second argument is the variable we want scanf to put the data in, prepended with the address of operator ampersand. So this is the variable that we want the data to be placed in. We will be covering ampersand in depth when we talk about pointers. So, revisiting printf. To print the value of a variable, you must use a format specifying placeholder in the first argument. Supply the variable as the second argument. Each data type has its own placeholder. And here they are! Haha! So, ints are D. You have modifiers, right? So H means short. U means unsigned integer. L means long. 2 L's means long or double long. Unsigned character is C. Signed characters are also C. Floats are F. Doubles are LF. Long doubles are capital LF. And this also gives you an idea of how big the thing is. So in C, integers are 4 bytes. Long ints are 8 bytes. This despite the fact that we are currently the word size of most operating systems is 64 bits, which is 8 bytes. So, long integers are the size of the actual word size of the system under most systems currently, but we still have most integers as 4 bytes, and this is primarily for historical reasons, but it is what it is. What happens if you declare a variable as int, but scanf asks for a string? It doesn't care. It'll try to put it in anyway. So, I don't know what signed char means, to be honest with you. I can't imagine what a signed char would look like. But we have it. So, what if we are only inputting a character? Would we still need to specify the kind of string we are putting in? Yes. Yeah, you would need to designate character. What is the difference between an integer and a double? A double is a double length floating point precision. So doubles are still floats, they just have longer, like, they're floats but they're long, basically. Percent sign I is also for integer. I don't think so. You should use these codes, and don't imagine that it's like just the first character of the data type, because that's often not the case. So C doesn't really check data types. The only reason that it has data types is for it to tell the memory system how many bytes the thing it's working with is supposed to be. So you can freely convert between, like, you can freely convert between any of these data types, but you'd have to do it manually. So, you know, I tell a lie to some extent. There are some differences, but you may have noticed during the this guy, when I printed out this character as a string, when I printed out this character as an integer, there was no like, oh, but you didn't convert it to an integer first, you know, and the reason for that is that C doesn't care. It's a number, right? In C, everything is a number. If you want to view a character as if it were a number, then go right ahead. And if you want to, you know, printf, I'm pretty sure that C is character. Some other number, then that's also totally possible. Like, okay, here's a good example. How about our program that reads numbers, hey? Let's say I didn't enter a number. Let's say I entered hello. Not only did it accept, like, not only did it not, it's given us garbage data, basically. And this is the type, oh, uh-oh. Hello? Am I still coming through? Ah, okay. So I does work then. Okay. Yeah. So this is the kind of stuff we're talking about when we say that C is not a safe language, and that it's possible to shoot yourself in the foot with it. So if you don't guard against not getting stuff that you don't expect, good. Then, you know, it'll still just let you do it, right? And the way that this is actually working is, like, I think if I put E-H, yeah. It's like, it's a string, so it must be reading pointers. So yeah, you know. The coupling is very loose. Or, like, but anyway. Hopefully, I don't know if I'm explaining that extremely well, but, basically, in your mind, you need to draw a distinction between the data itself as it exists in a binary representation in your memory system and how C interprets it. You get to control how C interprets it, but if the data is invalid, C doesn't care, and it will still work with it. So you are responsible for making sure that the data that it's operating on is actually valid. Another interesting thing about C is when you initialize a variable, the variable initially contains whatever memory was left over in that memory cell by whatever program was used it last. So, like, it's impossible to extract real data from it because it's, you know, there's no context to it. But variables and arrays and things like that are filled with garbage when you first use them. So you, like, in C, you have to develop this idea that variables can contain meaningless data. Like, variables can contain smelly garbage. And, like, you have to distinguish when it's not garbage, and when it is garbage, and when it's useful, and when it's not. That's your job. So yeah. Don't give me that bool. You may have noticed that on the foregoing the foregoing slide didn't have booleans on it. This guy. Boolean support was actually added to C in 1991. Or 1999, sorry. 1991, jeez. Unlike most other languages, Booleans are not a part of the C prelude. That is to say, Booleans are not loaded by default when you just, they're not just there. You have to load a library to get access to Booleans. In order to use them, you have to include the standard Boolean library. Add this line to your set of include statements. Before this library, C programmers would use integers to represent Boolean values. 0 was false, and any other value was true. 1 was typical. So yeah, this is where we're at, right? In C, C was originally released in 1972, and it took until 1999 for it to get Boolean support. There are no, you should come pretty quickly to the conclusion that, in C, data types kind of almost don't exist in the sense that they exist in Python. And Python's pretty loose with its data types. If you're normally a Java programmer or something like that, we're kind of in Wild West territory out here. Especially if you know anything with a very well developed type system, you basically don't have a type system in C. Not anything that would resemble anything a programmer would modern programming languages. A lot of work goes into writing good type systems for them. A lot of math goes into it, and C has basically none of that. The only thing that C is really concerned about is how big it is so that it knows how much memory to allocate. And that's only because it needs to know how much memory to allocate. Everything else is up to you. So, doesn't bool come with the standard library where it just outputs 0 or 1? Okay, so when I'm talking about bools here, I'm talking about, using true or false literals, right? But, yeah. They still had logical operators, right? And they still had, comparators, obviously. But, having actual true and false values show up in your code, that was something that didn't come until 1999. So, more memory concepts. Variables are units of memory that have been assigned an identifier. The amount of memory allocated is dependent on the data type the variable is declared with. The specific arrangements of 1s and 0s at the memory location the variable indicates is the value of that variable. So, the value of a variable is a series of 1s and 0s. That's to program in C, you need to start thinking in binary. A variable may be read from without disturbing the underlying memory. When a new variable is assigned to a variable, or when a new value is assigned to a variable, the underlying memory is overwritten with the new value. So this should be nothing new. This is how variables work pretty much anywhere. In Python, variables don't need to be declared with a data type. It uses dynamic typing. The Python interpreter manages the memory representation of the variables. The user is protected from these and other low-level details. In C, the type declaration tells the memory system how much memory to reserve for the variable, so the information must be present up front. This is known as static typing. Variables in the same program will not necessarily be allocated to adjacent memory cells. So in Python, you don't really care where your memory is stored in memory, right? But in C, it actually does matter whether your variables are adjacent to each other or not, because you can screw things up and read them. So you can read the wrong variable by not using an array correctly. You know, the most probable thing is that you will just get garbage, but it is definitely possible if you have a variable that is sitting in memory after an array and you overread the array, you will eventually read that variable. This is where we are in C. So, operator, get me Chicago. Here are some operators for you. So increment and decrement are things that you probably this will be new to you if you've only done Python, because Python doesn't have these. Negation, arithmetic addition, arithmetic subtraction, multiplication, division, and modulus. Notice that there's no distinction between integer and floating point division. It's just polymorphic. The increment and decrement operators, plus and minus minus, respectively, either add or subtract 1 from the operand. Plus and minus use implicit assignment, so no assignment operator is required. Whether the operator is prefix or postfix affects the semantics. If the operator is prefix, the increment is executed before the expression which contains it, and if it's postfix, it is executed after the expression which contains it. Because of this implicit assignment, using plus or minus on an integer literal is a syntax error. Yes. Is increment plus equals 1? Yes. Although postfix and prefix are important. So, here's an example of the difference between prefix and postfix. Let's say we had variable 1 and variable 2, both assigned to the value of 5. If we print variable 1 with postfix increment, and if we print variable 2 with prefix increment, variable 1 will print as 5, but by the end of the program it will be 6, and variable 2 will be 6, and by the end of the program it will still be 6. So there you go. Increment and decrement. The most common use of increment and decrement is while you're incrementing or decrementing the variables used in loops. So yes, to answer the previous question, are there for loops and while loops? There are while loops, yes, but you don't have for loops in the Python sense. You should abandon hope, all ye who enter, who were over-reliant on for loops in Python. What's an integer literal? 5 is an integer literal, so 5 plus is nonsense. A bitwise guy, eh? So, bitwise operators are kind of cool. And we'll start with them next time. We should be able to finish this topic this week, I think, for sure. But yeah, very briefly about what for loops in C. Syntactically, you do have a for loop, but the problem is that it's basically just syntactic sugar for a while loop. I should have it here somewhere. For. There we go. Yes. So a for loop is just like a few different statements that have been grouped together on one line, but it, like, semantically it's a while loop. Okay. So here's some questions. No. Yes. Is the for loop equivalent kind of like do while? Yes. Why no for? Yes. Yeah, you're just gonna have to learn how to use you're just gonna have to learn how to use loops, like while loops. You're just gonna have to learn while loops, dudes. Could line 3 be replaced by var1 var2 equals? Yeah, no, you can't. Avery. Where is it here? There. So no, you can't like ultimate. You can't do multiple assignment in C, but you can initialize more than one variable on one line by separating them with commas. How are you supposed to function? Well, first you decide what the return value of the function is, then you choose a function name, then you choose arguments, then you write the body of the function. That's how you function. Yes. So why didn't plus plus work on var1, but it worked on var2? Very important question. It did. It just did so after the print statement. So it printed the stuff first, then it incremented var1, because the operator was postfix. So for loops, yeah, they're like they're one of the better things in Python. Yeah, I like how Python does for loops. In other C-based languages, like C#, you get like a for each loop, which basically is a Python for loop. But yeah, no, it's okay because you're not really going to be working with data at that level of abstraction. So, yeah. Had to give for loops a nerf. They were a bit OP. They were a bit OP. Another thing that in Python you get a lot of stuff for free. But yeah. Yeah. So the final value is going to be 6 for var1. It just displays as 5 because this print statement precedes it being incremented. Yeah. Yeah, both of these accomplish the same thing at the end. It's just the order in which they do so. When in doubt, just do postfix. Or just include it on one line by itself. So, if we write code using var1 after the printf for var1, then the value of var1 would be 6 and not 5. Yes, correct. Correctamungo. So, alright. If there are any further questions, I'll take any further questions, but otherwise I'm gonna go get myself some lunch before my next lecture. The 3MI3 class is gonna kill me because I assigned an assignment in a language that like a bunch of them never took because they didn't take the course that I thought they all had as prerequisite. It's gonna be an interesting class. Because basically the solution at this point is like, well, you just have to learn it. We'll throw some tutorial material at you, but like, see, the problem is, unless you know a functional language, there's nothing that really does what a functional language does. So, yeah, bit of a sticky wicket. When am I going to add better TV emotes? It's got YouTube support now. I don't know what that is, and probably won't set it up because of that. But yeah, a lot of people were asking for like Twitch emotes in 1MD3. could have them going on, like, in the, in that sort of blank space underneath my head. You want emotes. We want emotes. We want emotes. Yeah. I'll tell you what. If I can manage to work my way out from underneath the mountain of work that I have to do this week, plus, you know, all of the work on my thesis that I've been neglecting, I might find like 5 minutes to see if it's possible. Well, see, I'm not really official yet, right? Because, like, I'm not a YouTube partner, because I still don't have 1,000 subscribers. So, get me more subscriptions, and maybe there's emotes in your future. Anyway, take her easy, folks. Have a good Tuesday. All that jazz.